Okay, so what we would like to do today is introduce you to a research project of ours. Maria has already said it's called Grounded Theory Analysis as a Basis for Authentic Language Using CLIL Contexts. And just to explain how we got to this project, Georg and I are both language teachers and teacher trainers at the University of Teacher Education in Austria, as well as at the University of Vienna. And what we realized amongst our students, but also in schools, especially in CLIL contexts, is that teachers typically have problems when they teach English in CLIL contexts. There are a number of challenges. One of the most obvious challenges is probably lexis, so vocabulary. And then what happens most of the time is that teachers basically look everything up in dictionaries, and then this is what they use. But the problem is that in authentic language use, this is not always, the right structure or the right word that they have found. So what you get is basically a mixture of what they think is right, what they think something like a concept from science should be expressed like in English. But the problem is that this might also result in, incorrect materials or incorrect language use. So what we try to do is investigate authentic language use in CLIL contexts, and we did that through a corpus linguistic study. So what we did was we compiled a mini corpus ourselves, and we tried to have a look at the language as it is used by native speakers in the field of science, for that matter, so that we can learn from this in a CLIL context. So we did that using the grounded theory framework. Here you see a very short definition of grounded theory. So it's a collection and qualitative analysis of data as a basis to construct a new theory grounded in the data. And underneath this definition, you see 4 generic steps that we try to stick to in our study. For our study, more specifically, this will have to be changed as follows. So we had a look at key stage 2 science materials as a basis to develop a new perspective on language. And the generic steps that I have just described to you look like this in our study. We compiled a language corpus, which we coded. And basically, we try to find out how specific language functions are distributed across the corpus, and what other kinds of data we can filter out from this analysis. And we are hoping to provide a foundation which is helpful when you create CLIL materials, or when you teach in CLIL contexts, in different kinds of teaching contexts, obviously. This is why we have arrived at these research questions, which you see here. Basically, we were interested in 4 different aspects. The first aspect, as I have already mentioned, had to do with the language functions and how they are distributed across the science corpus that we compiled. The second aspect had to do with specific language structures. So how are different concepts in science expressed in authentic English, and also what kinds of lexis is used in order to do that, and which implications do our findings have for teaching in general at different kinds of levels. We had a look at the primary level, and the reason why we did that was because in Austrian primary schools, teachers are supposed to use CLIL when they're teaching English. And the problem is that teachers in primary schools, in Austrian primary schools, are not necessarily trained language teachers. So this is a challenge, and this is why they need a lot of support. Now, basically, what you see here in this little Venn diagram, the overlap between the age range in Austrian primary schools and the age range in British primary schools, for that matter, overlaps in key stage 2, so ages 7 to 11. And so this is why we chose this specific age group to have a look at. I have to say, though, that the methodology that we used for our study, as well as the insights gained, can also be useful for different kinds of teaching contexts, which are beyond the primary context, obviously. Okay, here are a couple of specifics of the CLIL corpus. As I have already mentioned, it focuses on Key Stage 2. We had a look at science materials. So these were basically science textbooks that were available to us, which were published between 2014 and 2016. We used MaxQDA and nconc to do the analysis. And here you also see the frequency of tokens and types that we have in the corpus. Total, we coded 6,286 segments. We identified 27 language functions, which seem to be very frequent for the topic of science in the corpus. There are 69 different code types that we discovered across 29 topic areas. Okay, so, and this is what the coding system looks like. So this is a screenshot from MaxQDA, as you can see. So we basically coded at the sentence level, and then we always decided what kind of language function a specific sentence, could be related to. So for example, here at the top, you see instructing, which is not surprising because when you look at the materials, there are lots of there's a lot of language basically instructing learners what to do or to complete a task or something like that. The same goes for WH questions, but we will get into more detail about all of these things in a moment. I just saw that Georg is with us right now. Georg, can you carry on? You are still on mute.
Can you hear me now?
Now we can hear you.
Okay, so good morning. Sorry for logging in so late. I had a lot of issues there. Anyway, so as Ronald has just described, we have these codes, and we developed these codes during our coding sessions. And what you can see there is the, as Ronald said, the most common one is instructing, which is no surprise. Now, if we can see the next slide, yes, no, the previous one, yeah, next, no, this one, yeah. So we are now going to show you how we did this. We took the function describing cause and effect, and on the next slide, you can see how this works. So basically, on the right, you've got the PDF, and we marked the section where we thought this would be describing, and we can see with the arrow then that we allocated this description, this function. Ronald, can you switch? Yes. Okay, so this is how it works. This is how what it looks like. And here you can see on the next slide, this is the page, and there you can see the sentence which we tagged as describing cause and effect. Now, we did the analysis on 3 different levels. We chose the corpus as a whole, so all the course books which we had a look at, all the Key Stage 2 course books we had a look at, and then we did another analysis of the subject, so like, for example, biology or physics, and the third level then was the topics within these subjects. And by using our corpus, we can now have a look at the various functions there. So we looked at function types on the corpus level. So what kind of functions were being used? How were these functions distributed? And were there function clusters? So clusters like, for example, describing, what kind of describing was being used. So we had a lot of different levels there. And you can see now, this is the general overview of the functions, and the most prominent one there at the top is, we can see that a little later on the next slide, is instructing. And you see that this is a frequency of 16.04%, and all the others. Now, when you look at Key Stage 2 materials and at these science materials especially, it's no surprise, as we said, that there is a lot of instructing. But in this case, we can show exactly how many instances of, for example, describing, expressing a purpose, etc., are being used. So it's not just guessing. This is supported, our ideas are supported by statistical data, and this is the difference between, you know, the gut feeling and what we did. Now, on the next slide, you can see that the green bars, they show you functions of describing. So they all describe things in different ways. These are the function clusters. So, for example, describing facts and states, describing cause and effects, etc., and describing appearance. Now, if you look at describing appearance, for example, that's not very common. Whereas, for example, overall describing and states and facts is quite a common thing. We will talk about this a little later when we have a look at the learning aims and at the cognitive levels. Okay, so the next slide shows you asking questions. And we see that we have a lot of questions there. They are the kind of orange bars there. And again, if we move down a little, we see that the WH questions, for example, are very, very prominent. Now, we would expect that this is the case, of course, because guiding questions, WH questions, of course, are necessary in teaching and are often used. Now, on the next slide, what you can see is what kind of interrogatives were being used. And we have identified 6 interrogatives which were used in our corpus. And if you look at this more closely, you will see that one interrogative, a very prominent, is missing, and that's the interrogative who. So it's only what, which, how, why, where, and when. And what is the most important one, and which comes second. Now, if you look at the what questions on the next slide, you can see the combination. So what is, what happens, etc. And this will help us later on. And I think Ronnie might have mentioned this. One of our ideas was to provide some kind of insight, or to get some insight into Key Stage 2 materials, so that we can replicate some of these strategies in our teaching materials. And so here we see these are very common questions. These are the most common questions that are being used in native speaker materials for Key Stage 2 science. If we look at the next slide, you see this is what comes up when we look up the word which, and a little on the, and you see the combinations, right? Like which of, for example, which one, which organ, etc. So different uses of the which interrogative there. Again, these can serve as models for writing materials. Now, if we move on to the subject level, we chose the subject of physics, and we had a look at the functions there, the structures, and the lexis. So what kind of vocabulary is being used there as well. Again, we have the overall the overview of functions, and on the next slide, we see that describing, for example, cause and effect, is more prominent than instructing when it comes to to physics materials, key stage 2 physics materials. And again, the WH questions come third. So there are slight variations, but on the whole, I identified these kind of general levels and also the frequencies. Now, if we look a little more closely at describing cause and effect, that is our focus at this point, we see that certain constructions are used more often than others. So the first one is the most prominent one with 39 instances, is something behaves in a certain way because. So giving a reason by adding a subclause with the conjunction because. The second most frequent structure is when something happens to something, it reacts in a certain way. So when ice is warmed, it melts. The when sentence, the subclause at the beginning, and so on and so forth. So you can see these are the structures that are being used in order to describe and express cause and effect in these key stage 2 materials.
And if I may interject here quickly, as you can also see, this is where it gets really concrete and where it gets interesting as far as methodological implications is concerned, obviously, because if you are a language teacher or a CLIL teacher, or even in an EMI context, if you know that these are the structures are the most frequent ones, for example, then this has methodological implications. So you would then, for example, be in a position to target these structures in your teaching, to prepare your students to use these structures, and so on and so forth. We will get back to that a little later when we talk about methodological implications. So maybe I just carry on, Georg.
Yes,
when
yes.
we have a look at the subject level and we look at the lexis, then this kind of analysis also provides us with useful insights as far as content words, action words, and common phrases is concerned. And again, from a teaching perspective, this has implications because these are probably the terms that you would focus on first, because you simply know that in the materials, they tend to occur quite often. Excuse me. So we have just listed the 15 most frequent words here. Obviously, the list is much, much longer, but just to give you a sense of the kinds of words you would find, as far as the subject physics is concerned, for example. And when you have a look at the content words, it's probably not surprising that content words such as water, light, science, materials, and so on, these things are, of course, concepts that occur quite often in relation to physics, and this is why they're also high up in the ranking here. Now, something else that you can do with this kind of analysis is once you have a look at the action words more closely, so the verbs that are quite often used, then you find out that they all relate to different tiers of Bloom's taxonomy. And we have tried to color code the words here on the left so that you see how they relate to the different stages of Bloom's taxonomy. So for example, all the words in red have to do with the lower order thinking skill of remembering, whereas all the words in orange have already to do with understanding. And what's interesting here is that when you look at native speaker materials, then you find that most of the things that you find in the topic descriptions, or most of the action words used, they all target lower order thinking skills and not so much higher order thinking. I mean, arguably, it's not as clear cut because all of these different kinds of thinking skills overlap. Usually we have this pyramid in order to depict Bloom's taxonomy, but it's probably more accurate to depict it a little bit like this. So you can see once we do that, it gets much more complex. But the point though is, or at least this is one of the things that we concluded from our analysis, that the authors of most science textbooks try to deliberately keep the language at a very simple, manageable level for primary learners. As I said before, targeting lower order thinking skills more than anything. This is of course not to say that learners do not have to analyze or evaluate things. They surely do, but in terms of degrees, it's probably more on the side of lower order thinking skills here. So we have another slide here just to show you how complex Bloom's taxonomy actually is when we look at how it is applied in practice. And the question now, of course, is how useful such a model is for analysis like the one that we did. Probably the pyramid is a little friendlier in that respect, but we just kept this slide in because we wanted to acknowledge that things are not as clear-cut as they seem.
Can I just step in and with a remark? What we found out is that these lower order thinking skills, if we take the pyramid slide again, these thinking skills, this hierarchy, this taxonomy, is also the basis of the national curriculum in England. So if you look at the national curriculum, you will have these thinking skills laid out in the curriculum, and this is also the reason why you find these steps in the materials for Key Stage 2. So this was just an aside, but just to remind you, it's all based on the national curriculum in England.
Okay, and then when we have a look at the topic level analysis, we can do a very similar thing as before. We can again have a look at different function structures in lexis. Just to illustrate that with an example, we have chosen the topic of forces. So when you have a look at the distribution there, then obviously it changes again. And you would find different structures which are more prominent right now, which look like this. And again, this would be a useful starting point if you are a language teacher or a CLIL teacher, so that you know what kinds of structures you wanna prepare with your learners and you wanna target so that they can manage these structures as well. Here we have another example. This is magnetism. Again, you have a different kinds of distribution as far as the functions are concerned. And again, when we have a look at the lexis, then you see we have obviously different content words and different action verbs. But again, this is useful information for a language teacher or for a CLIL teacher because these are statistical data which you can build on, basically. Right, George, do you want to take over?
Yes, thank you. Now, on this slide, you can see the use of the word gravity. And this is quite interesting because then if we look at how these terms are used, the next slide is slightly bigger. And there you can see, for example, the sentence, gravity is a type of force, or the pull of gravity on us. More force gravity has on you, etc. And by looking at these structures, we can then, of course, learn a lot about how things are being expressed, and especially how they are expressed by native speakers. And this can again be the model for producing our own materials. On the next slide, you can see our methodological suggestions. So, for example, the sample data provide a list of very common words that are being used in these materials. So action words like attract, make, etc. And on the right, you can see ideas how these words can be taught, for example, as total in a total physical response way. So how are two people, for example, attracted to each other, etc. Pull, push, repel. So there are a lot of these methodological ideas, and this is by no means a comprehensive list. These are just a few suggestions, but you can use these words then and can pre-teach them. You can make them the students familiar with the meaning of these words, which are then important when you talk about forces and in this case about magnetism.
And so something that I would like to add to this list here is, of course, the methodological ideas which you see here They stem from the context that we were concerned with. As I said before, we were looking at the primary context. If you are in a different teaching context, for example, if you are in an EMI context or a CLIL context, upper secondary or whatever, then maybe some of these ideas are not as appropriate. So for example, I'm not really sure whether a very, very useful technique such as total physical response would work in an EMI context, but it surely does with primary learners, for example. However, other ideas could work in an EMI context, especially when you look at them as ways of scaffolding content. So for example, classification tasks or problem-solving tasks. This is something that could definitely be a takeaway from this kind of analysis here as well.
Yes, and the same applies, of course, to the next row. Then there we have the because structure, and again, how can you teach this? And yeah, everybody has to adapt these suggestions, of course, to their specific situations. And well, this is up to teachers using this. If we move on, as a summary, we can say that we found specific distributions of functions at different levels of content, which is quite interesting. We want to make sure by looking at these distributions, we want to make sure that we find the characteristics of K2 materials, and that would also help us to target the learner group we are aiming for. So a lot of the problems that arise when you do CLIL is that the materials are way beyond the grasp of the students, and by looking at these functions and also how they are being how they become visible in the texts themselves, we can learn how to imitate them and how to replicate them. So specific lexical structures are also dependent on the subject, as might be expected, and also specific linguistic implementations are interesting, especially when it comes to lower order thinking skills and higher order thinking skills. That is the Bloom's approach. And this is something which can also help producing materials that are useful and effective in a classroom situation.
Now, speaking of which, all of these findings are quite useful for a number of different areas. And we have tried to list some of these areas here. So for example, when you have an understanding of how different functions, lexes, and structures are distributed across a specific corpus or across a specific topic, then this will help you to select more appropriate materials. It would also help you to even design materials which are authentic, because you have models that you can use as the basis for material design simply, or models that will be the basis of the scaffolding process, as well as differentiation, because you can maybe simplify an authentic structure if need be. It might also have at a larger level effects on syllabus design, surely on teaching practice, not only for language teachers, but also for CLIL teachers, or as in the Austrian case, for primary teachers who are not trained language teachers, but who have to kind of start the process of language teaching through CLIL. And of course, in teacher education, which is our field of expertise, because we can direct our students to these structures and simply show them, what's important to focus on, especially when you want to provide your learners with an authentic learning experience. So this was basically it. Thank you all very, very much, and we're looking forward to your questions.
Thank you.
Thank you.